welcome to the video. So for this video, you can ignore the first slide because the first slide is a review of what was on the quiz. The second slide reviews percent ionization, which we need to go over because the AP exam really likes to ask about percent ionization, and I want to make sure we get it. So here it says calculate the percent ionization for a 0.15 acid solution, that's this year's acid solution, that has a Ka of this value. And whenever you're asked to find percent ionization, this is an x squared problem, because you have to find the H plus concentration, and to do that, it's an x squared problem. So if we set up the x squared problem, we have the Ka, so 4.0 times 10 to the negative 5, okay? And then we have the molarity of the acid, which goes down on the bottom, and we have x squared, okay? And we can cross multiply, and then square root, and then we get x is equal to 0.002, if we do that correctly. Now that is our hydroxide. I keep on saying hydroxide. That is our H plus concentration. Okay, so this here is equal to the concentration of H plus. Alright, and now we need to find the percent ionization. So if we look at the formula, okay, the amount of H plus goes on the top. Okay, and we divide it by the original concentration of the acid. Alright, and we get, and then you have to multiply it by 100 to get it as a percentage, and you get 2% about. And with sig figs, it would be 2.0%. So those are how you do those types of problems, which again, I actually didn't put, there was one of them on the first free, I think the second free response question on the quiz that you guys just took. Okay, now one thing I didn't talk about, which the AP exam likes to ask, is what happens to the percent ionization as you increase the molarity. And if you take a look, as you increase the molarity of the acid, the percent concentration goes, the percent ionization goes down, right? So here we have very dilute acids, and here we have stronger acids, okay? And the question is why? So why is that relationship hold? And it actually is a Le Chatelier's argument. So we saw on the graph that a acid with a lower concentration has a higher percent ionization. And the question is, why does that make sense? So as you dilute an acid, okay, why does the percent ionization goes up? Okay, well this long paragraph here explains that. So when you add water to a solution, the concentration goes down of both HA and H plus and of all the things in the acid reaction. Okay, now remember, Le Chatelier says you want to shift the reaction in the direction that counteracts the stress. Okay, well the stress is a decrease in concentration. So like again, we have HA, and it dissociates into H plus A minus. So the reaction is going to, when you add water or dilute an acid, okay, the reaction is going to shift in this direction, okay? And the reason why that is that this direction has two particles. See, it has two particles in this crazy sort of like paragraph that I wrote. It separates into two particles, right? Whereas if it goes this way, if it shifts this way, there's only one particle. And when you're shifting this direction and bringing it to two particles, and we just diluted it by decreasing the concentration, shifting this way is going to increase the concentration even more, okay? And that's going to lead to greater ionization if you're shifting that way. Thus, when you dilute solutions or decrease the concentration, the percent ionization goes up. This is a multiple choice that practices some of the math skills that we've been doing. So it says, what is the pH of a 0.05 weak acid? If the pH is 3, what is the percent ionization? Okay, so the first thing we have to calculate here is the H plus concentration, because we know that percent ionization is equal to the amount of H plus that you have over the concentration of the acid. And this is easy. If the pH is 3, right, then the hydrogen ion concentration is that. So for Pi, we know that. So this is 1 times 10 to the negative third. And we know that this is the total molarity of the acid, which is 5 times 10 to the negative 2, okay? Because again, I just put this into scientific notation. And then we're going to multiply this by 100, and if you wanted to put this in scientific notation, that's that. So if we do this math, this is a little bit difficult here, okay? 1 divided by 5 is 0.2, okay? And then remember, you subtract exponents, okay? So negative 3 minus negative 2 is negative 1. Okay, now this is not in scientific notation. Okay, this number here is not in scientific notation. Okay, so we have to move this over one more, and that gives us 2 times 10 to the negative 2. And then we have to multiply it by 100, okay, which, and 100 in scientific notation is 1 times 10 to the second. Okay, now if you remember, 2 times 1 is 2, and exponents add, and these add to 0. So the answer is 2%, or with sig figs 2.0, but it doesn't matter because multiple choice, so that's the answer. So again, this here was sort of the math I wanted you to see. Okay, if you have to move the decimal place to the right, you have to make the exponent one more negative. This is the first part of this lesson. Now we start like sort of a different topic, so I'm going to upload this video and make a new video for the second part of the lesson.